Hello everyone, in this video we'll be solving problem 452, minimum number of arrows to burst balloons. The problem statement is we are given the size of the balloons that are planted on an x-axis and we need to figure out how many minimum number of arrows do we need to burst all of the balloons. Instead of reading through this problem statement, let's use the example to understand what the problem statement is asking us to do and then think about the solution. Here's the representation of all of the balloons with its starting and the ending index when planted on an x-axis with color coding. The maximum number of arrows that I will need is n, where n is the number of balloons. I can use one arrow to burst each balloon, but we need to calculate the minimum ones. And to do that, we need to figure out which of these balloons have an overlapping area which we can use. If you are shooting an arrow along the y-axis, it can burst any number of balloons that are in the way. Basically, we need to figure out how many overlapping areas are there across multiple balloons on which we can shoot minimum number of arrows to target all or maximum number of balloons. With this input, we can shoot an arrow anywhere between 2 and 6 that will burst the two balloons, yellow and green. We'll need to use one more arrow and shoot it anywhere between 10 and 12 to get the blue and the pink air balloons. As we used two arrows, the output is 2. Now let's discuss how we can figure this out programmatically. Because this is an interval based problem, we need to make sure that we do some kind of a processing before we start solving the problem. And for this problem, the best approach is to sort the input array. Because we have two indexes, the starting and the ending, sorting it using the end index of each balloon will be more beneficial. I will explain the reason later once we dive deeper into the explanation. After sorting this using the second index or the end of the balloon, my array should look something like this. To figure out if there is an overlap, you can use this formula where we'll check the ending of the current interval if it is greater than the starting of the next interval. If this condition suffices, it means there is an overlapping area. For example, if we take these two as our first and second elements in the array, the first entry which is 1, 6, its ending index is 6, and the next interval is 2, 8, which is represented here, its starting index is 2. Because 6 is greater than 2, it means there is an overlap. So we can shoot an arrow anywhere between 2 and 6 and take down both of these balloons at the same time. It's like shooting two birds in one stone. But what if there are more elements in the array which could also have some overlapping areas? This is where the sorting of the original input will be helpful. Because the array is sorted based on the ending index, we can continue the iteration to check the same condition with the next interval until it is sufficed. If the condition is not met, it means that there is no overlapping area, so we need to stop the current interval and start building a new one with the next element as the starting balloon. For example, here the next element is 7, 12. As 7 is not less than 6, it means the criteria is not met. So there are no overlapping areas between the first interval and the third interval. So we can't burst both of them in a single arrow. So we stop the current iteration, which was using the first entry of balloon, and then start a new one with 7 and 12 as the starting point. So for the remaining iterations after 7, 12 interval, E of I will be 12 and S of I plus 1 will be 10. As the condition suffice, that means there is an overlapping area between the two balloons, so we can burst them together using a single arrow. With this solution, our time complexity is n log n as we are sorting the input array based on the end index of each balloon and then running a for loop to identify the overlapping areas. While the space complexity is O of 1, that is constant space, because we are not creating any additional collection, we are just maintaining one variable to record the number of arrows we need to burst all of the balloons. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by sorting my input array points based on the end index of each balloon and then initialize my arrows, setting the default to 1 and the previous end variable, which is set to the first entry in the sorted array's end index, that is the balloon's last index. I then start the for loop starting with index 1, that is the second element in the array, and then compare its corresponding starting point with the previous balloon's end. If the condition is satisfied, it means that there is no overlapping area between the current interval and the previous interval. So we increment the arrow because I need a new arrow to burst that balloon and change the previous end with the new one. If this condition is not satisfied, it means there is an overlapping area between the previous one and the current one. So we continue to use the existing arrow to burst that balloon as well. Once this for loop is complete, we will return the number of arrows as our output. This code, when submitted on LeetCode, beats 65% of the submissions in terms of runtime and 26% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.